Okay, so today we'll solve two questions from complex analysis. Question number 22 from Gate 2022 and question number 37 from Gate 2029. So let's start. Okay, so today we'll solve Gate 2022 questions. So this is a question from complex analysis. This is question number 28. So it is saying that the radius of, you have to find the radius of convergence of the following. This is a power series given. So you have to just find the radius of convergence. Okay, so in order to solving this is the NPTEL reference. Okay, so let's try to solve this one. So what the series is given, n bigger than 0, 3 to the power n plus 1, z to the power 2n, but z belongs to complex number. You have to find the, so this is given, to find the radius of convergence. So let's first first see there is some formula for radius of convergence and what is radius of convergence. Let fz equals to, so this is a general form of power series Cn z minus a whole to the power n for n equals to 0 to infinity. So this is a power series where z is a complex number, Cn are complex numbers also, and a is some complex number. So it is called the power series centered at a. So the radius of convergence, R is a non-negative real number, or it may be infinity, such that the series converges if mod z minus a is less than r and diverges if mod z minus a is bigger than r. So this is called, then this r is called the radius of convergence. Okay, so inside the radius of convergence the series will converge, and the formula for and r, and this r we can compute it in terms of, there is some nice formula. So from here we can compute the easily the radius of convergence of a power series. Then we can find the radius of convergence by the following formula. So what is the formula for radius of convergence? Then R is given by 1 by lim sup of mod Cn to the power 1 by n. So this is the formula for radius of convergence. We will use this one to find the radius of convergence of the series. So for that, notice that we have to write in terms of z. So this is center here, z. For our case, center is basically 0. We have to write in terms of zn and the corresponding coefficient we have to find. Now we have n bigger than 0, 3 to the power n plus 1, z to the power 2n. So here center is 0, it's fine, but notice that here it is z to the power 2n. So you have to write, it is not in this form, right? So you cannot directly apply this formula. You have to reduce it into in this form, then only we can apply this formula. So we'll reduce this to that form. So how you will reduce? Put in some 2n equals to k. Then what will happen? If you put 2n equals to k, then it will become n. So 2k is bigger than 0, 3 to the power. So n equals to k by 2. It is k by 2 plus 1 z to the power k. So this you can write also. And note that here k is even also. So 2n equals to k means k should be even. Right. So this you can, let me again write it in terms of n, because k is dummy variable, you can write anything. So k bigger than 0. This is same as k bigger than or n bigger than 0. N should be even. 3 to the power n by 2 plus 1 z to the power n. So let denote it by something Cn z to the power n. Then what is Cn? Where Cn, what is Cn? Cn is 3 to the power n by 2 plus 1 when n is even, and 0 when n is odd. Right. So this is our sequence. So you have to find this lim sup of this sequence. Right. So what is this? Note that this sequence, it has two convergence subsequence. It is not basically convergence sequence. It has two convergence subsequence. So here the note that in the formula it is lim sup. So you have to find the subsequential limit which is maximum or supremum, right? So let's find. Then lim sup of n tends to infinity Cn to the power 1 by n. So this is same as, because 3 to the power n plus 1, this is a positive number, so one sequence will goes to 0 and other sequence, so lim sup is the bigger limit, so it will be same as limit n tends to infinity of this, right? 3 to the power n by 2 plus 1, so this is positive whole to the power 1 by n, right? Because this is the, because other sequence will goes to 0 and this will be the bigger limit will. So this is same as the lim sup and same is the limit of this sequence. And what is the limit of this sequence? So limit n tends to infinity 3 to the power 1 by 2 plus 1 by n. So limit is basically root 3. So therefore the radius of convergence R, which is 1 by this lim sup, which is 1 by root 3, right? So what? No, so this is the radius of convergence. So what you have to find? Oh, you have to find it in the round of 2 decimal places. So if you write down it, you can see that this is, you can write it into 0.57 or 58. Round of 2 decimal places. So what we have got? The answer is 0.58. So the radius of convergence of this series is 0.58. Round of 2 decimal places. Okay. Okay, any question? No. Okay. So question number 28 done. Then we will move to the next one. Question number 37. It is from 2019 Gate. It is again from complex analysis. Okay, so today we'll solve Gate 2029 question. This is a question from complex analysis. This is question number 37. What it is saying? Let a region omega is given, x plus iy such that x lies from minus 1 to 2 and y lies between minus pi by 3 to pi by 3. So this is a rectangle in xy plane is given, so in the complex plane, and the transformation is given that it is z goes to e to the power z. So this map this region omega to the region S in the complex plane. Then you have to find the area of the region S, and 4 options are given. You have to find which one is correct. Okay. So in order to solve this, this is the NPTEL reference. You can look into it. Okay. So you have to find the area of a region. So what it is given. So note that for the first we need a one result. So in order to finding the area of a certain under some conformal maps. So let us one result. So if f from some domain U to a few is conformal. So conformal means basically this is means which map which are angle preserving. So whenever that so this map is analytic, whenever the derivative of a map is non-zero, so then we can say that this map will be conformal. So suppose F is a conformal, then area of FU, this is basically given by integration over U mod F dash Z whole square dx dy. Okay, so this is the area formula. So note that, let me sketch. This is very easy. How you can see it. So note. Let me see how this will come just only easily. So what is area of some region? Area of f of u. This is just the integration over fu. Suppose let's say f map from xy plane to suppose f is a mapping from this is xy plane to uv plane in the complex plane. So then area will be fu du dv, right? So this will be the area of the region fu. Suppose this is some region u and this is fu. Right, now if you now make the change of variable, then what will happen? So suppose let me, here we need one more result. So this, we know this. So let me write one more result. So you have to prove that this should be equal to this one, right? You have to show this one. If f is holomorphic at a point, if f is holomorphic, at some point z, and if we write f of xy by f of z, means we are viewing it as function of two variables, real function. Then from this, so capital F is a function from R2 we are viewing, and F is a function from C. Then F is differentiable in the sense of real variable, and you can write down the Jacobian determinant. So this is the Jacobian matrix for capital F at the point some xy. So this will be given by mod f dash z whole square. So this side it is the determinant, basically Jacobian determinant. Okay, so basically Jacobian determinant of capital F is equals to mod f dash z whole square. Now as area of fu is basically double integral over fu du dv. If you now make change of variable, so then what will be this? So viewing f as a function of fz as capital F of xy. So this will be some uv. So where it is given, so therefore, so this is same as a change of variable over the integration over u j f Jacobian determinant. When you do the change of variable, it will come Jacobian determinant. So basically this is the determinant, and dx dy. And what is this Jacobian determinant? By the above result, so this Jacobian determinant is mod of f dash z whole square dx dy. So this is the area. So whenever f is conformal, this is the area. You can use this one or anything, whatever you want. If you are viewing as a real variable function, then you can use as this formula. If you are viewing f as a complex variable function, then you can use this one, right? So here note where we have what we have given. So here rho is our region is given as such that x plus iy, x is from -1 to 2 and y is from -π/3 to π/3. And f is a map from omega to s, where it will map, basically it will map z to e to the power z. Fz is e to the power z. So note this map is conformal because you can see that this map has derivative to be non-zero. Note f is conformal. So therefore we can use this formula to compute the area, or this one, right? So therefore area of f omega, therefore area of s, which is same as area of f omega, right? So which is given by double integral, so by this formula. So if you view it as a real variable function, then it will be over omega Jacobian determinant of z capital F xy times dx dy. So you have to find the, so what is this capital F? Here what is capital F? Note that capital F of xy, what is this? This is basically f of z, right? So f of z is e to the power z. So this you can write e to the power x cos y, comma e to the power x sin y. So f is a function from R2 to R2, right? So you have to find the Jacobian determinant of this f. So Jacobian determinant of f, some point xy. So suppose let's call it this is uv. So then it will be del u del x, del u del y, del v del x, del v del y. What is del u del x? Del u del x is e to the power x cos y, del u del y minus e to the power x sin y. What is del v del x? Del v del x is e to the power x sin y. And what is del v del y? E to the power x cos y. So this is determinant of this. So determinant of this will be e to the power 2x cos square y plus sin square y. So which is e to the power 2x. So this is the Jacobian determinant. So therefore area will be area of S, which is by this one, area of S is given by this one, omega determinant of Jacobian dx dy. And what we have got, this Jacobian. So what is omega? Omega is this region, minus 1 to 2, x is from minus 1 to 2 and y is from minus pi by 3 to pi by 3. So this minus 1 to 2, so let me write it here. Minus pi by 3 to pi by 3, and Jacobian determinant is e to the power 2x dx dy. So now find the integration. So in y variable it is independent of y integrand, so that we have first integrate it out. So it will be 2 pi by 3 into integration of this e to the power x e to the power 2x, and evaluate you have to minus 1 to 2. So it will be pi by 3 into e to the power 4 minus inverse. So pi by 3 e to the power 4 minus e to the power minus 2. So we have got the area of this S is given by pi by 3 e to the power 4 minus e to the power minus 2. So let's see which option is correct. First option is pi by 3 e to the power 4 minus e to the power minus 2. So option A is correct. So therefore other options are, all the other not matching. So option number A is correct. Okay. Okay. Any question? Yeah, this formula just basically the, in real variable you know the what is the area of certain region. Just integrate the characteristic function of that set, right? Suppose area of some set, it will be integration over that set, characteristic function of that set, right? So that we have used here. Just I don't know the explicit name, just so first what we have done here, let me explain you. Preserving, so whenever you suppose, so this is the so then right now you, so this is just the characteristic function, right, over the fu. So area of fu is the characteristic function over fu and the integral over the whole UV plane, and because here it is the characteristic function over fu, so the integral reduces to the area over fu. So this is just the simple formula for real variable R2. So for any set, here fu is the set, this set has area, integration over that set, just so this is the, and now you make the change of variable because you know that f map this domain u to fu, so you make the change of variable. So then it will change whenever you make change of variable, Jacobian will come up for the change of variable. So what is, it will be the, but here f is a function from C, so then you have to view it as a function from R2 to R2. So that's why I write it in capital F. This, that's why we need F to be viewed in terms of function of two variable. So that's why we're writing, because function from C you can also view it function in R2. So that's why I've written it capital F xy, which is a viewing as a function of R2. And now you can show that if f is a holomorphic function, then f will be differentiable in the sense of real variable, means it's differentiable function in R2. Then this is the Jacobian is related to this f dash z whole square, determinant of this Jacobian. And now if you make change of variable, then the Jacobian determinant will come, and then we just replace this Jacobian determinant by this mod f dash z square. So this is just simple. This you can also remember this up to that line, this part, right? This is just only the real variable thing. Here we have transferred it to complex, means complex case in terms of little f. So that's why I have written in this form. You can view as, because f dash z you can simply compute, it is the e to the power z, right? What will be f dash z? In terms of complex, if you view, it will be e to the power z, and you take the mod, so it will be e to the power x, because e to the power iy will be modulus 1. So square, it will be e to the power 2x. So simply we will get just from here e to the power 2x dx dy. That you can also use, because no need to go to the real variable if you do not want. So but here we have to find the f dash z. So for that you can also use the Cauchy-Riemann equation, because Jacobian in the Jacobian part, it is basically because it is holomorphic, Cauchy-Riemann is same as the mod f z square using Cauchy-Riemann equation, right? This one, what I am saying. Here this is the ux, because using Cauchy-Riemann, ux equals to what, it will be ux equals to vy and uy equals to minus bx, right? So Cauchy-Riemann, if you use here the Cauchy-Riemann equation, you get basically mod f dash z square, right? So that is basically this mod of z f equals to mod f dash z square, you just simply using Cauchy-Riemann. Yeah. Yeah, change of variable, just for R2 it's change of variable, so that Jacobian determinant arise. Then you just use the Cauchy-Riemann equation to get that Jacobian is indeed the mod f dash z square. Any other question? Yeah, any other doubt? Okay. I think next class I will solve some functional analysis question. Yeah, thank you. Yeah, you can also see that what is this region will look like, that you can also draw. This is basically a rectangle, right? In omega, it's from -1 to 2, and from in the y-axis it's minus pi by 3 to pi by 3. And so what? So note here important thing that this map z goes to the power z. It's a conformal map. Yeah, but here one thing is that under conformal map the angle will be preserved, but the area may not be preserved. Here you can see that area of the omega. What is the area of the omega? Area of the omega, it will be 3 times 2 into pi by 3, basically 2 pi. But the area of the S, where it will map, it is not that same. So under the conformal map, area will not be preserved, but the angle between two curves, suppose you take any two curve, that line, boundary of the rectangle, again you can see that under that map, because here two boundary are orthogonal, again you can see that they will be orthogonal. And you can also draw the image under this set under the map e to the power z. Right. So because what is the map under, so note that x plus iy map to e to the power x plus iy. So if you take the mod, only matters it will be e to the power z. If you take the mod, e to the power x. So whatever the value of y, its modulus is always e to the power x. So a maximum value of x is 2. So what in the image, what will be the maximum value? It will be square, right? So the entire this line means for all y, for x equals to 2, that right hand side rectangle, it will map to the circle of e to the power circle of radius e to the power square. And what is then the left hand side, so for x equals to -1, so boundary of the rectangle, left hand boundary of the rectangle e to the power -1, it will map to the circle of radius e inverse. So basically so it will look like annulus where it will map, and y is for all y means it will cover the, but it will not be the entire thing. And again, so some part of the annulus it will map, so this region, the annulus with two circles of radius square and e inverse. And if suppose y is fixed and if you vary x, then what will happen? So maximum value of y is pi by 3, and if you, so basically it will map where it will map. So the image is e to the power x cos y and e to the power x sin y, right? So it will map basically the y axis to be the for fixed y, where it will map. So suppose take the point 0 comma pi by 3 in the complex plane. So x is 0, y is pi by 3. So it will map e to the power I pi by 3. So it has basically angle cos pi by 3 comma sin pi by 3, right? So theta equals to its pi by 3 angle. It will make. So basically it is a point of argument pi by 3 of angle pi by 3 in over the unit circle. So basically argument here it will be, so angle will be maximum angle will be tan pi by 3 and tan minus pi by 3. It will be basically inside these two line, right? So yeah, and also note that here the for y is in this region. So first component is e to the power x cos y, and second component is e to the power x sin y, and cos is positive in this region for y in minus pi by 3 to pi by 3 is positive. So inside the annulus only the right half matter, left half will not occur, because the first component means for y in this region minus pi by 3 to pi by 3 e to the power x cos y is always positive. So it's a annulus centered at 0 of circle, two circles are a square and e inverse, and again two lines cross. So it will be the right half of the annulus, not the entire right half but some part, because two lines are there. I think it will be root 3 line or 1 by root 3, some kind of. Right. So this will be the means S set will look like that. You can draw the image explicit. What will be the explicit image of omega under e to the power z map? So how the S set will look like? Yeah, this you can draw. So the line will be basically in the UV plane b equals to, because for any x cos y, what is the cos y and sin y? First component is cos y, second component is sin y. So just multiply by what is, so b sin y is some which, so we put something, just write in e to the power u equals to e to the power x cos y and b equals to, and find the b and u, then you will get. And question number 28 is just the, you have to find the radius of convergence. Yeah, that formula radius of convergence, it is basically that you know the root test for series, right? Just use the root test for series, you will get this formula. So you know the root test for a series will converge when it has r is, so you know it will be when the value of the limit should be less than 1. So from here we will get this r, and the formula for it is just called real kind of thing. Take the modulus and it will become a real series, then just use the root test, you will get this one. This one, this formula you will, because mod of cn into mod of z minus a all to the power n, with this will put an equals to this one and use the root test, you will get it. And here note that lim sup is required, right? Because in this case cn is, because sometimes it's 3 to the power means it's the series sequence may not be convergent, so you have to take the which means lim sup of that sequence, because there are two limits are there, 0 and 3 to the power and that one root 3. So because it's lim sup, so that's why that root 3 will come. So basically if you take, because lim sup why this is equal, because this is the bigger sequential limit, so that's why this is equal to the lim sup of that sequence. Yeah, okay. So we can stop for today. We'll meet in the next week. So that time we will solve some functional analysis question. Okay, bye.